Hello, class. Welcome to the next lesson in 8th grade Eureka Math. We are in Module 4, and today we're going to talk about Lesson 3, all about linear equations in X. So we're going to be doing linear equations, and the variable is going to be X. That's why it says in X, because we're using X as a variable, not Y, not Z. We could use Y and Z, but just to stay consistent, so without adding any surprises or any confusion, we're just going to stick with X. So we're on pages 19 through 27, so you need those workbook pages. You also need a page for your notes, and I hope you're already writing down these notes as I'm talking, because I'd like you to get the vocabulary down. I know it's a little bit of writing, so try to get the vocabulary in right now. We start with vocabulary. Our first vocabulary word is linear, and the other vocabulary word is equation. It makes sense that our vocabulary is linear and equation because we are talking about linear equations. It makes sense. Linear equations, you need to know what linear means, you need to know what equation means. So as you're writing down the vocabulary, write down that linear means it describes a straight line. Linear describes a straight line. If something is linear, it is forms a straight line. So even though we're talking about equations, they are linear because later in this module, we're going to start graphing them. And when we graph these linear equations, the graphs look like straight lines. So even though today, so far, we aren't really seeing straight lines, these are still linear because they still make straight lines. We just don't see the straight lines yet, but we will see the straight lines when we start graphing them. But before we start graphing them, we really need to understand them and see how they work. So that's what we're doing first. But regardless, linear means straight line. And an equation we've talked about in lessons 1 and lesson 2. Equation is a math statement or a math sentence with an equal sign. So an equation is a math sentence with an equal sign. What an equation is it's two expressions that are equal. Two expressions that are equal. So for example, you could say an equation is 2 plus 2 equals 3 plus 1. That's an equation. That's an equation because it has an equal sign. So on this side, we have an expression. 2 plus 2 is an expression, and 3 plus 1 is an expression because they do not have equal signs. But when we take two expressions and put them together, that makes an equation. Two expressions that are equal is an equation. So when we have two expressions with an equal sign, that's an equation. So that's basic math vocabulary today. So we're going to use that knowledge. And today what we are going to do, let me see if I can, yep, we have today's stuff. Today we will be determining if equations are true for certain values of X. So what's going to happen today is I'm going to give you an equation with X as a variable, and I'm going to tell you what X could be, and you are going to tell me if that's true. So I give you an equation, and I tell you X equals something, and you tell me if that is true or if that is not true. So we're going to be seeing if solutions work. We're going to be finding solutions. So really what it means is equations are true if both expressions on each side of the equation are equal. So if the expressions are true, the equations are true if the expressions are equal. Basically, it looks like this. Let's do a true equation. Well, let me just steal this one. The one I did before, 2 plus 2 equals 3 plus 1. That is true because 2 plus 2 is 4 and 3 plus 1 is also 4. But if I said 2 plus 2 equals 3 plus 2. Obviously, that is false. That is not true. Because 2 plus 2 is 4, and 3 plus 2 is 5. 4 does not equal 5. So that is false. Or we could say not true. So basically, that's what we're doing today. We are finding if equations are true or not true. They are true if both sides are equal. They are false or not true if the sides are not equal. So if something is not equal, we say false or not true. So I do have an example for you using x as a variable, because today it's not going to be this easy because we are talking about linear equations in x. We're not just talking about linear equations. We're talking about linear equations with a variable x. So here is an example of what we might be doing today. So I will give you an equation like 4 plus 15x equals 49. So you get the equation. And I'm going to say, is this equation true when x equals 2? So what we'll do is we'll put x, instead of x, we'll put a 2. So we do 4 plus 15 times 2 instead of times x, because x is 2, equals 49. Then 15 times 2 is 30, so we get 4 plus 30 equals 49. 4 plus 30 is 34. 34 does not equal 49. It's not true. So x equals 2 is not a solution because it does not make an equal equation. It is not a solution. But what happens when x equals 3? When x equals 3, we put 3 instead of x in the equation. We get 4 plus 15 times 3 equals 49. 15 times 3 is 45, so we get 4 plus 45 equals 49. We get 49 equals 49. That is true. 49 is 49. So x equals 3 is a solution. So that's what we're doing today. I'm going to give you an equation. I'm going to tell you what x might be, and then you tell me, is that true? Is that what x is? So that's the lesson today. That's the example. What I'd like you to do right now is maybe pause the video a little bit, go back and finish any notes you did not finish because I might have talked a little bit too fast. And then you can unpause the video when you are ready to go ahead and work on today's exercises. For everybody who paused the video to catch up on their notes, welcome back. For everybody who's just waiting for the video to keep going, you're still here, so no welcome back. Let's go to some of the exercises for some practice. Exercises are on page 19. So this is what it looks like. How many exercises? We got exercise on page 19. We got exercise on page 20. And that looks like it. So we're going to work on pages 19 and 20. Looks like we have 7 exercises. Let's get to work. So, exercise 1. Is the equation a true statement when x equals -3? So, x equals -3. In other words, is -3 a solution to the equation? So, x is -3, and this is the equation. Okay, so I'm going to copy the equation down myself, making sure I get it right. And x equals -3. So my next step is every time I see an x, I'm going to substitute -3. So 6x turns into 6 times -3. 5x turns into 5 times -3. And 2x turns into 2 times -3. Now, according to GEMDAS order of operations, I need to do all this multiplication first. So I'm just going to go straight across and multiply. 6 times -3, well, 6 times 3 is 18. 6 times -3 is -18. So I get -18 plus 5. 5 times -3 is -15 plus 8. Plus 2 times -3 is -6. Now I need to do all my adding. This might be a little bit confusing if you're not familiar with negative numbers and adding and subtracting with negative numbers and all that fun stuff. So what I would recommend if you struggle with this is make yourself a number line. Make yourself a number line going from negative 20 all the way up to 20, and that should be able to help you add and subtract negative numbers. Just count. But negative 18 plus 5 means we lost $18, but we got 5 back, so we get negative 13. And this way, I'm just going to do, I don't need to do all of them at the same time. I'm just going to do negative 15 plus 8. If I have negative 15 and I get 8 back, that means I only have negative 7. Negative 13 I already solved. Negative 6 plus negative 7 plus negative 6 means I have negative 7, I lose 7, and then I lose 6. How many did I lose altogether? 13. There we go. Negative 13 equals negative 13. Both sides are the same. So negative 3 is a solution because both expressions are equal. Both expressions are equal. So negative 3 is a solution. I can even write true right here if I want. But this is really my answer. Negative 3 is a solution. Good enough for me. Let's move on to number 2. So that's well, let me summarize. That's exactly what we're doing today. We get an equation. They tell us what x might be, and we tell them, yes, that is a solution, or no, it's not a solution. So we're having to, so it's substitute, solve, and answer. Let's do the same thing for number 2. Does x equal 12 satisfy the equation? Well, this equation. So x equals 12. Satisfy means fill, means complete, means make it true, make it right, means is x equals 12 a solution? Satisfy is just another way of saying, does it work? Does it make the equation happy? So here's our equation. That's what x is. So let me copy my equation first. 16 minus 1/2 x equals 3/4 x plus 1. And x equals 12, so every time I see an x, I need to put in a 12. 16 minus 1/2 times 12 equals 3/4 of 12 plus 1. Now, GEMDAS tells me I do my multiplication first. So 16, so I need to do this part and that part first. 1/2 times 12. Well, half of 12 is 6. So this turns into 16 minus 6. Half of 12. 3/4 of 12 might be a little bit more complicated. Let me show you how you can do it. I'll do the work over here. 3/4 times 12 is 3/4 times 12 over 1. And then what I like to do is I like to, okay, there's a 4 in the denominator. Let me see if I can make that go away. Well, I know 12 is 4 times 3. So now I can cross out the 4 in the denominator and the 4 in the numerator. Now this just gives me 3 times 3 on top of 1 times 1, which is 9 on top of 1, which is 9. That's multiplying fractions, something you've been doing since 5th grade. If you need a little help, send me a message and you say you need help multiplying fractions, and we'll have a little private one-on-one lesson. I'll help you multiply fractions. Or you can always go to Khan Academy and search for their lesson about multiplying fractions. But when you multiply 3/4 times 12, multiply the fractions, you get 9. And don't forget to bring the plus 1 back down. So now we have 16 minus 6 equals 9 plus 1. 16 minus 6 is 10. 9 plus 1 is 10. 10 is 10. That is true. So x equals 12 does satisfy the equation. This is my explanation. Because both expressions are equal. And that's the answer. When it says explain, it's wanting you to write a sentence answer, not just give a number. It's wanting an answer to explain how you know. So that's exact same thing for 1 and 2. Let's see, and we have a true, I'm hoping they give us a false soon, because that would make this a lesson a little bit more interesting. Let's see if number 3 is one that is going to be not true. Number 3, Chad solved the equation 24x plus 4 plus 2x equals 3 times the quantity 10x minus 1, and is claiming that x equals 2 makes the equation true. Is Chad correct? First, I don't know if Chad's correct. Let's check Chad's work. So this is the equation he had, 24x plus 4 plus 2x equals 3 times the quantity. That's what we say when we multiply by parentheses. We say 3 times the quantity, 10x minus 1. That's just a math vocabulary word. And x equals 2. So every time I see an x, I'm going to put in a 2. So we get 24 times 2 plus 4 plus 2 times 2 equals 3. 10 times the quantity, 10 times 2 minus 1. And I change it to brackets because I put parentheses on the inside. So we use brackets instead of doing 2 parentheses. It might be confusing if I just do only parentheses. I did brackets. It just means the same thing. It just is something different so that your eyes don't get confused. Okay, let's use GEMDOS and see what we should do first. Well, we should do that one. We should do that one, multiplication. And we should do the multiplication inside the parentheses first. So let's do this. 24 times 2 is 48. Plus 4 plus 2 times 2 is 4. 3 stays on the outside. I need to do the brackets first. 10 times 2 is 20 minus 1. So that was all the multiplication. Next step, let me finish up the parentheses. So 20 minus 1 is 19 on this side. 3 times 19 is 57. The way I did this, by the way, I did 3 times 20 is 60. 3 times 1 is 3. 60 minus 3 is 57. That's how I did it in my head. I didn't really do 3 times 19. I did 3 times 20 minus 3 times 1. So 3 times 20 minus 3 times 1 is 60 minus 3, which I know is 57. That's mental math, so I did not have to get out a calculator. You should be practicing doing it mental math like that. So we did this side of the equation. Let's do this side also. Let's start with 48 plus 4. 48 plus 4 is 52. 52, then we do 52 plus 4, we get 56. And now when we do both sides, we get 56 equals 56. Well, I'm sorry, Chad. 56 doesn't, we get 56 equals 57. Sorry, Chad. 56 does not equal 57. So Chad is wrong because, and there's the word because it says explain, because the left expression equals 56 and the right equals 57. They are not equal. That's my explanation. Basically, 56 does not equal 57. So x equals 2 is not a good solution. X equals 2 is not the answer. Now, do we have to find the answer? No, not today. If you want to have some fun, you can try to find the answer, but you don't need to find the answer today. Today, you just need to tell me that x equals 2 is not the answer. You don't need to find the right one. You just need to tell me that x equals 2 is wrong. Chad is wrong. Okay, let's move on to the next one. Next page, page 20. By the way, we've practiced 3 of them, number 1, 2, and 3. If you feel like, if you want to, you can always work ahead, go faster than me, and then check your answers when I'm done. That is absolutely okay. If you think you know what you're doing, go ahead and work faster than me. I'm okay with it. But I'm going to keep talking, so because I'm talking and doing everything, I'm moving a little bit slow. But you can work faster, or you can just keep working with me. And we're going to do number 4 right now. We could do that together. Number 4, Lisa solved the equation x plus 6 equals 8x plus 7x and claimed that the solution is x equals 1/3. Is she correct? Explain. So Lisa said x equals 1/3. Is she right? Well, let's check her work. Let's start with the equation. X plus 6 equals 8 plus 7x. And x is going to be negative 1/3. This is always fun with negative fractions. Every time I see x, I'm going to put in negative 1/3. So I get negative 1/3 plus 6 equals 8 plus 7 times negative 1/3. Okay, let's do it. Let's do the left equation first. Negative 1/3 plus 6. It might be easier if you switch them around. So negative 1/3 plus 6 might be confusing, but what happens if I just tell you to do 6 minus 1/3? Doesn't that seem a little bit easier if I just switch them around like that? 6 minus 1/3. Or you could do 6 plus negative 1/3, which turns into 6 minus 1/3. Because the answer ends up being 5 2/3. That's your answer on that side. But let's look at the right side of the equation. We need to do 7 times negative 1/3. Multiplying fraction, we just get negative 7/3. Negative 7/3 is 2 1/3. So we do 8 minus 2 1/3. Now, the way I do this is I do the whole number first. 8 minus 2 is going to be 6. So I do 8 minus 2, and that gives me 6. And then I still have to do the minus 1/3. So then I do 6 minus 1/3. Well, 6 minus 1/3, you already know that one because we did it up here, by the way. I'm sorry, I'm covering it up. We do 8 minus 2, we get 6. Then we do the minus the 1/3. 6 minus 1/3 is 5 2/3 again because we took 1/3 away. So we get 5 2/3 equals 5 2/3. Lisa is correct. Lisa is correct. And it says explain, so I need to have the word because both expressions equal 5 2/3 when x equals negative 1/3. That's our explanation. That is a good explanation. That is what I expect you to write for your work as well. Are we having fun yet? I hope so. I know it's getting to fractions, so you might be freaking out a little bit, but just keep trying your best. Let's move on to number 5, and now we have Angel's work. Angel transformed the following equation from 6x plus 4 minus x equals 2 times the quantity x plus 1 to 10 equals 2 times x plus 1. He then stated that the solution to the equation is x equals 4. Is he correct? Well, Angel did some work. He simplified this equation. So first, let's see if he simplified it correctly. He started with 6x plus 4 minus x equals 2 times x plus 1. Well, let's check. He has 6x plus 4 minus x equals 2 times quantity x plus 1. And he says the answer, he simplified it to 10 equals 2 times x plus 1. Does this turn into this? Well, let's check. First, let's combine our like terms. 6x minus x. The 4 does not go with them because the 4 does not have a variable with it. So we do 6x minus x. We get 5x plus 4 equals 2 times x plus 1. Well, if you look at this, 5x plus 4 equals 2x plus 1. He said 2 times the quantity x plus 1 is over here, but for some reason he thinks 5x plus 4 equals 10. So I'm going to say Angel did not transform the equation correctly. Angel did not change the equation correctly because there's no way 5x, I don't know how he got 5x plus 4 equals 10. So this part is incorrect. So I'm going to say Angel transformed the equation incorrectly. That's the first part of my answer. Angel transformed the equation incorrectly. He did not do a great job of transforming that equation. But let's still check just for funsies if x equals 4 is a solution to the equation he started with. Let's take the equation he started with and see if x plus 4 works. Maybe he transformed badly, but he still got the right x. Maybe. I don't know. Let's check. So let's take what he started with and put the 4 in there. Every time we see x, we're going to put in a 4. And then we're going to just use arithmetic to solve. 6 times 4 is 24. Plus 4 minus 4 equals 2 times 4 plus 1. 4 plus 1 is 5. 2 times 5, I'll do that one first because it's easier. Now right here, 4 minus 4 is just 0. So I'm not even going to, I just saw that. I noticed that. I recognize that. And 24 plus 0 is 24. I'm sorry, Angel. 24 does not equal 10. 24 does not equal 10. So this one's wrong. Let's look at the equation he got. This is what he thought it turned into. Let's see. Let's put 4 here. 4 plus 1. Oh, his wrong equation works. So here we go. This is why he got 10. He says it works. He says x equals 4 works because x equals 4 works for this one. But x equals 4 does not work for this one. And this is what he started with. So he transformed incorrectly, so he got the wrong x. This is why you have to pay attention to all of a student's work. This is why I ask you to show your work. Because Angel got the right x for this equation, but he transformed incorrectly. So Angel is incorrect. He got the wrong answer to the equation he started with. So this is why it's always important to show your work so that your teacher and anybody helping you can see where your mistake was. Because Angel got the right x, but he started with a bad equation. He started with a bad equation, so he got a wrong answer. He did the math right here, but he did the math wrong over here. So this shows us what step he made a mistake on. Always a good idea to copy your steps so you know where they are. This is why we show our work. So sorry, Angel, you kind of know what you're doing, but you need more practice transforming equations. Or next time, Angel can just start with this one like we did and find out that x equals 4 does not work. Let's move on to number 6 and talk about Claire. Claire was able to verify that x equals 3 was a solution to her teacher's linear equation. But the equation got erased from the board. What might the equation have been? Identify as many equations as you can with a solution of x equals 3. So Claire knows that x equals 3. What could the equation have been? And it says write down as many as you can. And we can actually probably do this forever. So we can make, I'm going to make a little bubble map. X equals 3. What equation works with x equals 3? Well, I can say something as simple as 2 plus x equals 5, because x equals 3 works for that one. Or you can say x minus 2 equals 1. That also works when x equals 3. You can say 12 divided by x equals 4. That also works because 12 divided by 3 makes 4. You could say 8x equals 24 because 8 times 3 makes 24. Those are just 4 examples. They're simple examples. They're not super complicated because, well, I don't want to take a whole lot of time and try to figure them out while you're still working. If you have some time, see how many you can came up with. I just came up with 4 super quick. I came up with an addition, subtraction, multiplication, and division, just to give you 4 examples. You can come up with more complicated ones, like maybe something closer to this where x is on both sides of the equation if you want. But for number 6, this is just a fun little practice where you come up with what might Claire's equation have been. I came up with some super simple ones. If you like this, feel free to have a little bit more fun and come up with some more complicated ones. But I'm going to move on to number 7. Number 7 is asking kind of a theory question. Does an equation always have a solution? Could you come up with an equation that does not have a solution? Well, here's the answer. Does an equation always have a solution? No. Excuse me. I've been talking too long. Some equations do not have solutions. Because remember, in our notes, an equation is just a math statement with an equal sign. That's all an equation is. So I could say x plus 3 equals x plus 2. That does not work. It does not work. Because if x is 1, that means this does not work. No matter what you put in for x, it does not work. I could even write an equation like 2 equals 5. That's an equation. This is an equation because it is a math sentence with an equal sign. Now, it is a false equation, but it does not. There is no solution. So no solution to this one. You cannot find it. There is no solution to this one. You cannot find it. So yes, some equations will not have solutions. I don't think you'll see any of those today, but we will see them later in Module 4 when some equations just will not have an answer. So just so you know, it is possible for there to be no solution, But that's our exercises. That's our practice. Hopefully you understood everything. Hopefully you're ready to go. You know what you're doing. Let's look at the rest of today's work really quickly. Page 21 is your lesson summary, where they just summarize what we learned, where they talk about how to prove an equation is true. Both sides have to be equal. Both sides have to be equal. Page 23 is your exit ticket, which we'll do last, so I'll put that in the back. Page 25 is the homework helper, where they give you 3 more problems doing the same thing we just did, trying to prove if things are a solution or not a solution. So go through these if you need a little bit more help. I like how they give you the question, they give you the answer, and they tell you what they were thinking. So if you're still stuck, use your homework helper. Oh, the homework helper also goes on page 26. So they give you a couple pages to practice. And then your problem set is on page 27. And there are 4 questions on your problem set for practice. Number 1, given that 2x plus 7 equals 27 and 3x plus 1 equals 28, does 2x plus 7 equal 3x plus 1? Explain how you know or not. Number 2, is -5 a solution to this equation? Explain. So does -5 work in that equation? Number 3, does x equal 1.6 satisfy this equation? Explain. So does 1.6 work in this one? And then for number 4, use this equation to answer parts A through D. So you're using the same equation for x equals 5, x equals -8, and x equals 1/2. And then there's going to be some interesting fact you find after you do A, B, and C. What do you find after you do A, B, and C? I'm not going to spoil it for you, but you'll do A, B, and C, see if all these work in this equation to see the interesting fact. My answers to the problem set are posted on the Google Classroom, so you are able to check your answers to this, no problem. After you check your answers and you feel comfortable doing this math, then go back to page 23, your exit ticket, and work on the 3 exit ticket questions, all asking, are these solutions? So number 1, is 8 a solution? Number 3, is -3 a solution? Number 2 is a fun one, 3 equations that work with x equals 5. But this page 23, is what you take a picture of and turn that in on the Google Classroom to show me that you have mastered these skills. So that's what you're doing. Practice on the problem set. Turn in the picture of the exit ticket. And hopefully everything worked out well today. I will see you for the next lesson. As always, reach out to me if you need help with any of the ideas from this lesson, and we'll have a private meeting. But have fun. I'll see you for lesson 4.